So earlier we had seen when I divide here this voltage source of 9 volt with a voltage divider to the 4.5 volt. You see here we are grabbing this in the middle of the two resistors. Then we can, when we have divided this voltage to this point here and we make the yellow wire the output, then we expect, okay, we can grab here 4.5 volt. But when we do with a certain resistance, we had a 50 ohm resistance for tests. When we do that, well, we are dropping down on the output voltage of the voltage divider. And mainly that was because of the parallel situation of these two resistors here, the load and the divider resistor now. So I said we can do something as a remedy here, and we're going to try something with a resistor, so watch out. So here we have the 4.5 volt. So we take our friend BC 547 transistor and we put the base to this voltage divider output. We connect the collector of this transistor to the supply voltage, in our case 9 volt. The emitter of the transistor is our output, and there we will connect now our load. And so we connected here the load. And you see the voltage here is not much affected. But our new output point is now not in front of the transistor, but our new output point is here where the resistor is getting its voltage from here. And you see we are over the resistor at 3.765 volt. And that is a good thing, because before we dropped down over the output resistor, over the load resistor, we went down to around 400 milliampere. And now we are at 3.7 volt across this output load, and that is much more stable. And if we look at our voltage divider, also our voltage divider is quite stable, although there is this difference of 4.4 to across our output load 3.7 something, and we will explain that when we go into theory about this now. But the situation, again, it is much better than before. Output load has now 3.7 volts across this. This could make our helicopter, our drone, or whatever something work. We have not the 4.4 that the voltage divider gives us, but we have 3.7, and that is a good output thing, good output voltage. And let's visit this, why this is like this is in theory. And you can use this in practice, but let's look at why this is in the theory now. Okay, so this is our initial situation. We have a 9 volt voltage source. We go over a voltage divider and we close the circuit, and we take our output from the voltage divider from here. These two resistors have been 1K, so we expect the voltage to be equally divided to 4.5 volts at the output. And we see this pin here as an output pin. And then in our first approach, in the last video, we just connected this output over a load to ground. And then we've seen, oh, that doesn't work. The load draws, if it draws much current, then this current must also go through here. And if the current goes through here, this big current, the voltage drop is bigger, and we lose the 4.5, and we're left with around, in the bad situation, we were left with only 400 millivolts here instead of our great 4.5 volt. So now the new situation we created was, okay, let's not connect a load directly here, but let's use some form of a transistor. And it was a BJT transistor. And the way the way we connected it was like, okay, I go into here, that is my little transistor. Then I go into, with my output voltage, with 4.5 volt, I go into the base of the transistor here. And this upper part, really, the collector, so let's name that, that's B, the base, C, the collector, and E, the emitter of the transistor. And with the collector, we went up to the 9 volt rail directly. And our load now was our load was connected to this emitter now here. So our load of around 50 ohms, and from here went again to ground. So ground, or we can make the direct connection to here to have it neatly connected, everything. So instead of connecting to the 4.5 volt output directly, we made this awkwardishly looking trick, connect the 4.5 volt to the base, and then only the emitter to the load, and not directly the load to 4.5. And somewhere we had to connect the collector, and we collected it to 9 volt. And what we've seen here in the measurements was that the output here was around here 3.78 something. Let's say around 3.8 here at the output, 3.8 here volt at the output, which is not what we initially wanted, 4.5 volt, but it's better than only 400 millivolt when connecting load directly. So 3.8 volt is a big leap forward. And the way this thing works, so that's the situation. You can use this knowledge to make good use of voltage dividers and use their output voltage. But we can get even better. So, and first I want to explain you why this is here. Because the 4.5 volt, they drop over this base emitter, it's a diode, and you lose 0.7 volts across the diode here. And that's why you have 3.8 volt here and not 4.5. And the reason then why this current is going through and there is no additional current through here is that we get the current that is flowing through this 50 ohm resistor and the 3.8 volts across it. We get this current here, which is around 80 milliampere. We get this current not from this path, but we mainly get this current from this path here. Because the transistor has the property that if you say, okay, here you have a voltage and there has a current here in the emitter, then the current that the emitter is outputting, it gets to a small fraction, the current comes from here. So, and to a small, to a very much bigger fraction, the current comes from here. And it's all the factor how much current comes from the base path here and how much current is drawn from the collector here to get to that current. So let's calculate that. The current here must be 3.8 volt divided by 50 volt. What is this? 3 divided by 50 ohm. This must be 380 divided by 5 milliampere, around 76 milliampere, so roughly the 80 milliampere I told you about. We need here, and this 76 milliamps just come to a small fraction from here and to a bigger fraction from very much bigger fraction from here. And because this current that's coming from out of here is so small, it does not much affect our voltage drop here. And that is also why you have seen before that a small amount of current comes from here, and therefore the drop of voltage here is a little bit remarkable, but not quite too much. And but the very big amount comes from here, and therefore, yeah, that's a good thing. And we stabilized the thing to 3.8 volt. Now the question is, what if you wanted to have really 4.5 volt here? And also quite an easy solution. You have to watch out that if you lose 0.7 volt over the base emitter, that then you still end up with 4.5 here. So if you want to have 4.5 volt here, after losing 0.7, you must be at 5.2 here. And to get at 5.2 here, you have to divide the 9 volt differently. You don't have to divide it equal, so one resistor 1K, so 4.5 in the middle here, so you don't want to have 4.5 here, but you have to choose your resistors so that you end up with 5.2 here around. And then you gain 4.5 volt here at the output. Such a situation is often called an emitter follower, because what you put as a voltage here at the base, then this emitter follows the base. Just it's lower of 0.7, but in principle it follows what you put on the base, just 0.7 lower. Yeah, and that concludes that. I have an even better trick for you, but you can think of it of your own, or I'll make another video about it. If you replace this single transistor configuration here, this is a BJT transistor. By the way, I'm using often the BC547C here as a single transistor. It has a beta of oftentimes for a wide range of input of currents of around 200, but that's not too stable. Oftentimes BJT transistors are said, hey, take as beta the value 100 and you're good. So as a general rule of thumb, but in this concrete case with my transistor it's around 200. And if you don't use only one transistor here, but if you use two in a Darlington configuration, that could get even better here, the situation. And maybe I'll make a video about that, but you can think of it as your own. Google a little bit about Darlington transistors. I'll also make a video about that in some time, but there are videos out there. So you're welcome, cool thing, and see you the next time around.